All right, hi students. This is Mr. Clucky, and today you should be on, I believe this should be task 2 or task 3, but what we're going to go ahead and do is I'm going to help teach you how to do your graphing notes here. So I'm going to zoom in the corner. At this point, in addition, you should have your notes document pulled up from your Google Drive that you made a copy of from the Google Hyperdoc, so please have that accessible as well. But I'm going to go ahead and hit quick present here. All right, so let's talk about graphs, all right? Because graphs are something we're going to do quite a bit in class this year. All right, so first off, what is a graph? Okay, a graph is a picture that's going to that is going to help us understand something. So, and that something is going to be data. And remember, data is another word for evidence. Okay, so the reason we make graphs is because we've done an investigation or we have some evidence or some data that we're having trouble making a conclusion on. All right, oftentimes data can be tricky and evidence can be hard to understand what it's trying to I don't like to use the word tell us, but what the evidence is trying to convey to us. All right. So making a graph helps us make a picture representation of that evidence to help us see what are some of the trends or patterns that we can see. All right, and that helps us make a conclusion. All right. There are three types of graphs. They are the line graph, the pie chart, and the bar graph. All right. So let's start talking about line graphs. Okay, line graphs are a way that you can summarize two different pieces of information and see how they're related and how they vary depending on one another. All right, so they're a way for us to summarize at least two pieces of information. All right, and oftentimes one of those pieces of information is something over time. All right, it's something regarding time. So it could be hours of the day, it could be length in minutes. And another thing that I didn't put on this slide that often it represents is temperature. All right. So a lot of things will be compared, like temperature over time, people over time, um, growth over time. Right. They're going to compare two different things. Line graphs will both have an x-axis and a y-axis. Right. Remember, the x-axis will run horizontally, whereas the y will run vertically. And the numbers along each one of those is what we're calling a scale. Okay. So what does a line graph look like? Well, here's an example. This line graph here, we can tell is showing a comparison of the number of people that are in a store over time. So again, we're comparing two things. We're making a comparison between the time and the people. Okay. And the question says, what are some conclusions that we can draw from this? Right. So think about it. What are some conclusions that we can draw? One that I see right away is that at 1 o'clock p.m., we had the most people in the store. And at 10 o'clock a.m., we had the least people in the store. And one good thing with the line graph that we can see too is we can kind of make some trend decisions. Like for instance, the busiest store hours are 10 or are noon to 2, and the least busy store hours are 10 and 11 and 3 to 6. Right? So again, line graphs can help us compare data, and oftentimes they're used for temperature, time, and to compare a couple of different things. The next type of graph we're going to discuss is a pie chart. A pie chart is usually a circle that we divide into slices. All right, and we make a pie chart to help us compare percentages and to display what part of a whole something makes up. All right, and in order to make the data more clear, sometimes we put different colors in there. And with the colors, we do have to make a key. And this is something we'll talk about again at the end. But with the colors, we do have to make a key. So in this graph, we see favorite types of music. And you'll notice that we have different numbers here. And I'm not sure if these numbers are representing a percentage or if they're showing you a number of types of music. But notice from looking at the picture, we can see what percentage that's taking up. For instance, if this was just a perfect quarter, we would know that would be 25%. In this, right, we know that these two types of music combined make up a little over 50% of the favorites. So notice this helps show us percentages and parts of a whole. Another example would be this one. And notice again, this one shows us the percentage on the slices, but even without that percentage, we could see what it would be. All right, moving along. The next graph we're going to discuss is a bar graph. Bar graphs are a series of labeled bars that show different values, and oftentimes these values are going to show us a number of items, so an amount perhaps. The bars can run horizontally or vertically. And the numbers along the side of the bar graph we also call the scale, similar to the line graph. In this example, we see that this is a depiction of how long animals can hold their breath, and the bar graph is running horizontally because the bars are going left to right. If we flip this on its side, the bars would be running vertically because then they're going up and down. And again, we have a scale down here at the bottom showing us the number of minutes. Notice these are showing us an amount of minutes that these animals hold their breath. And while it is using time, it's not showing time progressing. It's showing an amount of time rather than between the hours of 10 and 2 as of the line graph. Another example of a bar graph, this is a vertical one. And again, we can see the amounts of pets that people own. Here, the scale is located on the y-axis. All right, probably the hardest thing with graphs are determining a correct scale to use. And remember, the scale is the numbers that are running along either the x or the y-axis, or sometimes both axes. All right, and the reason the scale is so important is because with an incorrect or an improper scale, you are going to miss out on a lot of information. So I've got two pictures here, right? I've got a picture right here and a picture right here. And my fun fact for you guys is that these pictures actually are depicting the same data. All right, the same data and evidence is being graphically represented by a line on both of these different graphs, and it's the same data. The only thing different is the scale. All right, so this scale starts at 0 and moves to 24, and we can see that each one of these boxes is representing $2 billion. So we go from 0 to 2 to 4, and the increments are going up by 2s. Whereas with this scale, it's still billions of dollars, but notice it's not starting at 0 anymore, it's starting at 20. And it goes to 22, so each box is representing 0.2, or 2/10 of a billion, instead of 2 billion as a whole number. And notice how that changes our line. Here our line looks straight, whereas if we change our scale, we can see, is it really a straight line? No, it's not. Right? We can see that it rose pretty quickly and then started leveling off, and then it almost leveled off completely, and then it picked up at a consistent rate again. So notice here that there are a lot more details in the second graph, which when we ask the question, which shows better detail, we would probably say the right graph, because notice how much more information you're missing out on if you would include this scale versus one that would start at 0. A great indication that you need a better scale is you would see all this wasted space at the bottom. Look at all that wasted space. And look at this graph, right? There's no wasted space at the bottom. In class, we would do an activity where we have a set of data like this, and we would make a new scale on this side. So I'll just talk through with you here. Notice how there's a bunch of wasted space down here. So that's a great indication that we need a new scale. Do we need to start at 0? Probably not. All right. And when determining a best scale to use, I always say find your lowest data point and your highest data point. So in this graph, our lowest is going to be 72, and we can find that right here as well. And our highest is going to be 91, found right here. So our scale needs to include both of those numbers. So what are two numbers we could use as our scale as a starting and stopping point that include both of those? Well, my guess would be, let's start at 70, because that would include 72, and we could go up to 92, which would include 91. And notice then, we would not have all this wasted space. We could start right at almost our data point. And I think that would show us a lot better detail than what this is showing us. For instance, we could see with greater detail how quickly some of these lines are rising by. So like I said, a great trick is to figure out your lowest and your highest number, and then find a scale that includes both of those and is closer to those numbers. All right, a few tips for making a graph. Right, there are 5 or 6 things, I believe 5 things that you need on each of your graphs that I'm going to request in class. And these things will often count as points. All right, so the 5 things you need are a title, a scale, units, a key, if necessary, and a legend. Okay, so the title is going to be what's going to be found above the graph, and it's going to describe what the graph is showing you. All right, usually the title is the first thing you're going to read on a graph, and it should tell you what it's showing you. The scale we just finished talking about, it's those numbers along either the x, y, or both axes, and we can change the scale to fit what data we have. The units are very important, and the units are going to be what you're going to label. All right, so whenever numbers are used, you have to indicate what those numbers represent. And even if it's not numbers, let's say it's a species of animal or something, we have to say what are those animals representing. All right, so we have to label it with units. Only 2 types of graphs need a key. Those two types are going to be a pie chart because they use colors and a bar graph if you choose to color it. So notice the only time graphs will need a key is if you have colors, and we have to say what those colors represent. And the last thing that I know my students always forget about is the legend. And the legend is a quick conclusion about your graph, usually 1 to 2 sentences. And that's usually found at the very bottom. So let's go ahead and see what these look like. Here's an example of a correctly made graph in class. Notice your title would go right here. You have your scale on both axes. You'd have your data plotted in the center. And notice you'd have a label labeling this axis and a label telling me what this axis is as well. And then our legend is right below with that conclusion. Filled out, it might look like this. Notice this is a pie chart. And the pie chart has a title telling us what it's about. First period science test preparation survey. That's what this is. It's what the data is showing us. Notice how we have a key because there are colors, and the key is telling us what those colors represent. And we also have the conclusion at the bottom. The conclusion in this graph is the majority of students in first period science did not know about the test. Now, an easy conclusion or an easy legend to make is I always say, pick out, well, what is the most thing on there? Or what is the least thing on there? Or what is one thing you can learn from the graph? So notice here, 85% of the students said, dude, what test? Which is how they got to the conclusion a majority of the students didn't know about the test. Here you'll see a label, right? Notice how the number is a percentage of students and not an actual number. All right, and that's where we're going to stop. All right, so hopefully that helps you feel a little bit more confident about graphing. In class, we'll have you make both handwritten and digital graphs. But at this point, you can continue in your learning exercises on the Google HyperDoc and move on to your next task. Thank you.